Hey guys, today we're going to do questions 12, 13, and 14. So we're almost done with our practice test. Let's begin with question 12. Jerry says that a square is a rhombus. So what she's saying by that is she's saying if you draw a square and consider all of its properties, that you could name it or classify it as being both a square and a rhombus. And the reason she says that is because it has 4 equal sides. And in contrast, Brianna says that a square is a parallelogram because it has 2 pairs of parallel sides. So Brianna is saying, well, we can take this shape here and we can name it both a square and a parallelogram. And the question asks you to figure out who is right, Brianna or Jerry. Okay, so Brianna says it's a square and it's a parallelogram. This is Jerry. This is Brianna. They want to know who is correct. Now, in order to answer this question, you're going to have to consider the features of all of these different shapes and decide if this shape satisfies the requirements for both a square and a rhombus, and if this shape satisfies the requirements for a square and a parallelogram. And then you're going to need to write a sentence that explains your idea. So just to refresh your memory, oh, I spelled rhombus wrong. Oh boy. Just to refresh your memory, once I fix this, the attributes of a rhombus are that it's a flat shape with 4 equal straight sides. Opposite sides are parallel. And opposite angles are equal to one another. Opposite angles are equal. Okay, so by that definition, I'm thinking that this square is a rhombus. I think it does meet the definition of being both a square and a rhombus. Now let's consider the definition of a parallelogram. Okay, so in order to be classified as a parallelogram, a shape must be a quadrilateral, meaning it has 4 straight sides, quadrilateral, okay? It has to have 4 angles, and opposite angles have to be equal to one another, or congruent would be another way to say it. Opposite angles are equal, or congruent is another way to say that. So that means that this angle has to be equal to this one, which it is. Those are opposite angles. And this angle has to be equal to this one, which they are because they're all 90-degree angles. So I'm wondering if it's possible to say that both are correct and then explain why. I'm going to leave that up to you. Okay, question 13 tells us to compare the total number of sides in each set of shapes below. Which shape, or which set, I should say, which set has more sides, set A or set B? And we need to write an equation to support your answer. Now this seems like a good opportunity to practice writing an equation. So let's begin by considering the number of shapes in set A. I can count 1, 2, 3, 4. I've got 5 shapes in set A. And let's see here. 1, 2, 3, 4, 5, 6. Each of these shapes has 6 sides. So that's going to be 6 hexagons. No, 5 hexagons with a total of 30 sides. And then I'm going to have to do the same thing for set B. count up how many shapes are there, figure out the total number of sides, and then compare them using the two equations to compare. Here's another opportunity for you to practice your writing skills. Emily says that every square is a regular quadrilateral. Do you think that her generalization is true? Yesterday we talked about the steps to proving a generalization. So the way to prove a generalization is to consider some example shapes that we think might support the generalization. Next, notice a pattern or something that all of the shapes seem to have in common, and then make a statement about the pattern that will always be true, even if we introduce other examples of shapes that are not currently shown in the set we started with. So in order to do this, let's consider the attributes that a regular quadrilateral must have. So a regular quadrilateral must have 4 straight sides, 4 angles, and 4 vertices or corners. The sum of the 4 angles must equal 360 degrees when you add them all together. Meaning you can have a right angle, you can have acute angles, you can have obtuse angles. However, in order to be a quadrilateral, when you add up all those angles, they have to equal 360 degrees. So that's why a quadrilateral can be a shape like this that has a combination of obtuse and acute angles. It could be a shape like this, or it could be a square or a rectangle. Any of these shapes would match the definition for a regular quadrilateral, even though they have different kinds of angles. The sum of the angles, meaning when we add this angle plus this angle plus this angle plus this angle, it's going to equal 360 degrees. Okay, so now your job is to think about Emily's generalization and decide whether or not she's correct, and then write me a sentence that explains why. And that's it for our practice test for the week. So now your job is to make sure that you upload all of your written work. Remember that I want to see evidence that you've been watching my videos and taking notes along with me. So a really great example of some notes that I would love to see, I would love to see a definition for a regular quadrilateral and definitions for other math terms that we've reviewed in the video. Let me know if you have any questions.